Okay, so what I did was I applied the small one into the rubber and I glued it into the rubber. This is just part of its size. I can pull it out and see it stretches at a little distance. This is the other part of the glove. The other part of the glove is attached to the inside of the bottom here, so it allows it to fold up inside of here and move inside of here. Now the same repeats to here and to here. And it flows from here, flows under there, the cap here, so that this will actuate this, this will actuate this, this will actuate this. So it'll flow to the extension of the human's arm. And there's electromagnetic. I'm also going to be using copper and aluminum. And I'm going to use a capacitor to phase into it. I have capacitors here. I turned this side. This is actually supposed to be the back part. Where the capacitor is at, in the back of here. So I'm going to add two of them to phase both of these. This capacitor is 450 volts, and I phased it into the beginning so that it runs from the top down to move the inside out upward. So it'll move this forearm by the joint area upward. So it's inside the interceptor shaft coil. So it'll move out. And I can push the sides and make an octagon out of each one of these pieces by putting them together and bending them to deform the shape, and using I can bend them to in a vise to deform the shape and then flatten it to make it square, and then flatten the other end to make it like an octagon. And then I can wrap coil wire around to make half of each part of the top and half of each part of the bottom with coil of wire, which will fit into the sliding shaft area. The Gauntlet has let me put this on. I will probably use another can, so I'm just going to put my fingers through the mesh of the coil. So I'm trying to get my hands through the other. Hold this thing, give you a moment. So, okay, okay, I don't know where my hands at. Oh, sorry. So, my hands, what can I do? Okay, sorry. So, the 4, this is how it goes, and it can move longer and longer distance. I'm going to coil up the fingers and all that, like the other. And the capacitor's on the back. So when I do form it, it's able to stretch. I don't need the scissor ring to separate the parts, because I was going to cut it along the sides and then weld all the wires together and actually put a frame on it, a guide frame, so that when I use the scissor rings, it will separate to open it up and also close when it closes the scissor ring, and also separate like individual Hall effect coils, solenoid sense, to move like a linear actuator. Each coil stack off another. Remove the aluminum and the copper, aluminum and copper unit. So I got my t-shirt, my sweater under here, so obviously you see I had a lot of room. It didn't take that much time to slip my arm into. This is the second. I'm going to try to switch it up and slide it out. Slide over my shirt, so I got to shake it instead of using power. So now it's shaken to the forearm part. So yeah, so making it big enough to push a human into the ear, not by the hand, but by the forearm brace to push up. And then I'm going to do the bicep to follow along with that. And I can still move my hand, just like a human being. I can tighten my fists and stuff like that, and touch my pinky without a lot of stress. And I'm going to add just a little bit more coils around the fingers and around the hand and stuff like that. So all this is going to be phased with Hall effect and synchronous. So the idea is to start the battery source, power source from the central. We're going to put the dome as a bowl dome in the sphere. The sphere within the central is in driver by a AMG driver 3-cycle, and use a DC alternator converter the AC to DC, and cycle it back, and that will give power to the rest of the system, to the capacitors and the ultrasounding driver for the transducer, and driven by ultra capacitors, the induced currents of voltage, and that will get it to repel and the solenoid push and pull, and there into the air. So the idea is doing like 500 feet of AWG 14, so I can get out of it. I believe that it was 17,000 and I think 600 something pounds. I do have that in writing online. Yeah, it should be like 17,260 pounds for two gauntlets. And actually, yeah, for one gauntlet actually. So, my name's Ray Morton, and goodbye. Okay, I'm rolling this around to make like a ribbon form all the way up, and then I'm gonna do the one all the way down. This is a metal and aluminum wire at the bottom, so I'm gonna do another ribbon right here, this kind down here. I'm gonna do one under the boot, going that way in the linear. Once I do one set, I can repeat it again, and repeat it again, and repeat it again. So this is 500 feet of wire, 500 feet. And the gauge is like two 16 gauge. I mean, 2 14 gauges thickness, or 14, yeah, 2 14 gauge thickness. 500 feet, so I'll do 500 feet here, wire, over and over, for a magnetic suspension linear solenoid. Then we'll go down here and do this part. See how this blends seamlessly in there? And we're gonna make it like a ribbon. And I got aluminum at the bottom. And as you see, this is 9 pounds of electromagnetic, regular permanent magnet hold, right? Okay, yeah, these are the magnet boots, and just put them on just to see the feel. They're kind of heavy. They're very heavy. Getting in and out of them, they're very heavy. So they're not a problem. Just shake it off and off my foot, and that's the internal. It's rubber, and they're permanent magnets. I still have to put the coils on here and stuff like that, and they're real heavy. Then I got it in a resin epoxy. I know to only use the bottom for that, and use the rubber for the top, the whole top structure. And the coils, after you grind it down, then I gotta put the coils on here. That's cheap, like a real boot or a sneaker. And it has about 450 pound, 455 pound pull force. Each magnet has 5 pounds, and there's 91 magnets, and they are 1.6 ounces. So that enumerates, I believe, 9 pounds and 1 ounce. So each pound is 9 pounds and 1 ounce, and that's not including the rubber boot, the rubber. So